Hi guys, welcome to today's tutorial. Today we'll be treating the topic frustums of cones and pyramids. So get your writing materials ready with your calculators. We will be right back.
To enjoy mathematics, you need to know the basics. We at Mathematics Simplified is here to make it easy. Ensure your notification button is on, like, subscribe, and share with friends.
Welcome back. Now, frustums can be referred to as the base part of a cone or pyramid. Alright, now what do we mean by this statement? If we look at a cone, let's have a cone. If we look at a cone, alright, this is a cone. If we should cut this cone on this horizontal, alright, we cut this cone along the horizontal parallel to the base. Now, we are having two shapes. On this other part, we have it as a smaller cone, while on this other part, we are having it as a half-cut shape. Now, this is what is referred to as frustum. So that's why I say frustum can be referred to as the base part of a cone or pyramid. Okay, now this cut part is what we refer to as frustum. Okay, while this forms another smaller cone. Now, this same theory is also applied to the pyramid. If we have a pyramid and it's cut that way, parallel to the base, now the smaller top forms a smaller cone, a pyramid, while the lower part forms a frustum. Now, in order to calculate the frustum, in order to calculate the volume of frustum, we are having it as the volume of the entire cone, volume of entire cone or pyramid minus volume of smaller cone or pyramid. So what this simply means, if this is our entire cone or whole cone, whichever, alright, the volume of this entire cone minus the volume of this small cone will give us the volume of our pyramid, our frustum. Likewise, for the pyramid, the volume of the entire pyramid minus the volume of the smaller pyramid will give you the volume of your frustum of pyramid. Alright, now at this point, let's look at examples on this aspect. Example 1 says, find the capacity in liters of a bucket 24 cm in diameter at the top and 16 cm in diameter at the bottom and 20 cm deep. Now let's give a diagrammatic representation of this. If we have our bucket, we know that for our bucket it's this way, right? Now, from the question, it's saying that the diameter on top is 24 cm and the diameter at the bottom is 16 cm. Okay, now the height from top to bottom is 20 cm. Alright, now for us to, they say we should calculate the capacity of this bucket in liters. Now for us to calculate the capacity of this bucket, which is the volume, well, capacity means volume. For us to calculate the capacity of this, we'll form this bucket to be a full cone. So if we draw this to be a full cone, so that we can be able to apply a formula, then we'll call this new height x. Alright? Now when we call it x, we can now, from this vertical angle point, draw a line dividing this bucket into two. Alright, now if we divide this bucket into two, we'll be having a triangle of this form. Let me turn it upside, okay? Let me leave it this way. We'll be having a triangle of this form. This is our x, this is our 20, and this is half of 24. Since this is from the center of the cycle, half of 24 will give us 12, and half of 16 will give us 8. Alright, now if we have this now, we can now calculate the volume of the cone. Now, we know that for us to find x, okay, since we have this as, let's bring out this smaller triangle as this. Now this is 8 and this is x. Now we can see these two are similar triangles. Now since they are similar triangles, we can equate them to be equal. Now this will become 12 all over 20 plus x equals to 8 all over x. Alright, you can see that the 12 all over 20 plus x, which is my height, equals to 8 all over x, which is my height. Now we cross multiply. This becomes 8 bracket 20 plus x equals to 12x. Opening up this bracket, we're having 160 plus 8x equals to 12x. Now we collect like terms. This becomes 160 equals to 12x minus 8x. Alright? Now, at this point, we are having 160 equals to 4x. So therefore, x equals to 160 over 4. X equals to 40 cm. Now, if we know that x equals to 40 cm, we can now replace it here, that x equals to 40, x equals to 40. Alright? Now, having done this, let's look at how to calculate volume of our cone. Now, our volume of entire cone, volume of big cone, volume of big cone. Alright, our big cone is this entire cone. Alright, volume of big cone, we have it as 1/3 pi r squared h. Alright, now this will become 1/3 times pi, which is 22/7, times r. Now our r for the big cone is 12 squared, times our height. Our height, remember, our entire height is 20 plus 40, which will give us 60. Okay? Now we are having this as 22 all over 21 times 144 times 60 all over 1. Now this will give us 22 times 144 times 60 divided by 21 will give us 9,051.429 centimeter cube. Now let's calculate the volume of smaller cone. Now the volume of smaller cone will be from this angle, from this point down, will give us the volume of smaller cone. From here down, forms our smaller cone. Okay, now which is this triangle. So we want to calculate volume of smaller cone still using the same formula 1/3 pi r squared h. Now this will give us 1/3 times 22/7 times our r now becomes 8 squared times h, which is 40. So this becomes 1/3 times, this becomes 22/21 times 64 times 40, which will give us 22 times 64 times 40 divided by 21. That will give us 2,681.905. Okay, now at those points, we are now going to do volume of frustrum, okay, will become volume of big cone minus volume of smaller cone. Now this is our volume of big cone is 9051.429. Okay, let me make it big. 9051.429 minus 2681.905. Okay, so this will become 9051.429 minus 2681.905. That will give us 6369.524. Alright, now that's our volume in cm cube. Okay, in cm cube. Now, but they said we should find it in, they said we should find the capacity in liters. So we know that 1000 cm cube equals to 1 liter. So 6369.524 cm cube divided by 1000, okay, is going to become 6.369524 cm cube. So to the nearest three significant figures, it will become 6.37 liters. Sorry, these are liters. So it becomes 6.37 liters. Now we've been able to calculate the volume of our frustrum, okay, which is the volume of the bucket which we are asked to calculate.
To enjoy mathematics, you need to know the basics. We at Mathematics Simplified is here to make it easy. Ensure your notification button is on, like, subscribe, and share with friends.
Question 2 says, a frustrum of a pyramid is 3 cm square at the top and 6 cm square at the bottom and is 5 cm high. Calculate the volume of the frustrum. Now, if we are to calculate the volume of this frustrum, let's have our frustrum first. Since it's a square-based pyramid, Okay? Alright, it's saying that the volume at the bottom here the volume is 6 the square cm is 6 cm, okay, is the square, and this is 3 cm on top. Alright, now for us to calculate the volume, and they say the height is 5 cm. For us to calculate the volume of this first room, we'll make it a complete pyramid. Okay? Now, if we make it a complete pyramid, now we'll call this height x. Okay? Now, from the middle of this point, we have our line passing through this center down to this center of our pyramid. So from here to here will give us 3. Now from this point to this point will give us 1.5. Why? Why are we having 3 and 1.5? They say that it is 6 cm. So if we have the radius, it becomes 3. And this is 3 cm. If we have our radius, it becomes 1.5. Alright, just like we did in the cone, let's bring out our triangle. We have the big triangle this way, where we have 1.5 and we have 3. This is 5 and this is x. Okay, this is for the big triangle. And for the small triangle, this smaller part of the cone, we have it as x and 1.5. Alright, now let's do our calculation. Now, for us to find x, we are going to have it as 3 all over 5 plus x equals to 1.5 all over x. Okay, let's cross multiply. This becomes 3x equals to 1.5 bracket 5 plus x. Okay, now opening up that bracket, 3x equals to 1.5 times 5 will give us 7.5 plus 1.5x. Okay, this 1.5, subtracting 1.5 from both sides, 3x minus 1.5x equals to 7.5. So x, okay, 1.5x equals to 7.5. So therefore, x equals to 5 cm. So our x is 5 cm. Okay? Now, bearing in mind that our x is 5 cm, we can now replace it with 5 and replace it with 5. Alright? Now, let's calculate volume of big frustum. Volume of big pyramid. Volume of big pyramid will become 1/3. Since it's a square-based pyramid, our volume will become 1/3 b squared h. Alright, where the b squared is our length times length. Alright, this will become 1/3 times 6 squared times our height, 5 plus 5, which will give us 10. Okay, now solving this out will give us 1/3. 6 times 6 is 36. So 3 divided by 36 divided by 3 will give us 12. So this becomes 12 times 10 equals to 120 cm cube. That is our volume for the big cone. the big pyramid. Now, volume of small pyramid. Volume of small pyramid will become, still using this formula, that will become 1 over 3 b squared h, right? Which will now give us 1 over 3. Our b here will be 3 times 3 squared times our height, which is 5. So this will give us 3 into 9 will give us 3 times 5, which is 15 cm cubed. So now at this point, volume of frustrum will be equal to volume of big pyramid minus volume of small pyramid. Okay, now our volume of big pyramid is 120 minus volume of small pyramid 15, which will give us 105 cm cubed. Now, that is the volume of the frustrum we have here. Alright, now we shall be looking at more examples on how to calculate our entire work. We'll do a little revision on all we've done so far.
To enjoy mathematics, you need to know the basics. We at Mathematics Simplified is here to make it easy. Ensure your notification button is on, like, subscribe, and share with friends.
Our next question says, a bucket is 12 cm in diameter at the top and 8 cm in diameter at the bottom and 4 cm deep. Calculate its volume in terms of pi. Now, what this simply means, we have a bucket, alright? Now, if this is a bucket, it says the diameter on top is 12 cm and the diameter at the bottom is 8. Okay, now the height is 4 cm. Alright, now that we should calculate its volume. For us to calculate its volume, we first of all make it a full cone. Alright? If we make it a full cone, then we can now calculate our x to find the volume of this entire cone. Alright, now bringing out our big triangle, where we have our x and our 4. Now the question is, what will this point be? If you know the answer, put it at the comment section. Alright, now this point is going to give us 4. 8 divided by 2, 4. Now, what will this point be? Our radius here will become 6. Why? 12 divided by 2 will give us 6. Now, if we do that, next, we bring out a smaller triangle, which will be 4 and x. So from here, we can calculate the value of x to be 6 over 4 plus x equals to 4 over x. Now cross multiplying, alright, cross multiplying, this becomes 6x equals to 4 bracket 4 plus x, which will give us 6x equals to 16. 4 times 4, 16 plus 4x. Alright, so 6x minus 4x equals to 16. So therefore, x equals to 8. How did we get 8? 6 minus 4 will give us 2x. 2x equals to 16. X equals to 16 over 2. Alright? That's how we got 16. And that's how our x will be equal to 8. Now, if x is equal to 8, we can replace it here that our x is 8. Now, knowing that our x is 8, we are now going to calculate volume of big cone. Volume of big cone. Now, our volume of big cone, our formula is 1 over 3 pi r squared h. Now, which is going to be 1 over 3 times pi. Since they said we should leave it in terms of pi, we are not going to include the pi value. Alright? Times pi times our radius, which is 36 squared. Okay? 6 squared times our height. Our height now for the big one will be 4 plus 8, which is 12. Okay? So we are having 36 times 12 will give us 36 times 12 will give us 432. 432 all over 3 pi. Okay? Now if we break this down, 432 divided by 3 will give us a 144 pi. Okay? That's for the volume of the big cone. Now, volume of small cone or smaller cone will become 1 over 3 pi r squared h, which is 1 over 3 times pi times our r is 4. 4 squared times our h, which is 8. Okay? This becomes 1 over 3 times 16 times 8. That is 128 all over 3. So 128 divided by 3, 128 pi, please, divided by 3 will give us 42.67 pi. Now, volume of frustum will become our volume of big cone minus volume of small cone, which is 144 pi minus 42.67 pi. Okay, now this will give us 144 minus 42.67. That will give us a 101.33 pi. Now they said we should leave it in terms of pi. So this will be 10133 pi cm cube, since we are leaving it in terms of pi. Alright, now we'll be looking at some questions from what we've treated before. Now, it says a cylindrical casting of height 8 cm and external and internal diameters 9 cm and 5 cm respectively. Calculate the volume of metal in the casting. If you've watched up to this point, please like, subscribe, and click on your notification button to get more updates as we upload more topical teachings for you. Alright, in solving this, we know that let's represent our cylindrical casting as this. Okay? It says its external diameter is 9 cm. Alright, and it has another smaller one inside this way. Okay? Now, they said this diameter here is 5 cm. Alright, now they say we should find the volume of the metal in the casting. That means the volume of metal used in casting this cylinder. And we know that from our previous study when we looked at hollow objects, okay, because this is an example of a hollow object, it has a hole. Remember, we said that hollow objects are objects that have holes inside, while composite objects are objects that are whole. There is no hole in there. I hope you understand what I'm saying. Alright. Now, in calculating this, we'll first of all calculate volume of external. Okay? Our volume of external, since this is a cylinder, we'll be using our formula for cylinder, which is by R square H. Volume of cylinder, our volume equals to pi R square H. Alright? Now, they say from the question, it has a height of 8 cm. That means our height is 8 cm. So for the volume, you're having 22/7 times R. Now, since our diameter is 9 for the external, half of it will become 4.5 times 4.5, that is the square, times 8, which is our height. Okay? This is going to give us 22 times 4.5 times 4.5 times 8 divided by 7 will give us 509.143 cm cube. Alright, now volume of internal. This is external. Okay, volume of internal will become, still using the formula, pi R squared H will become 22/7 times our R now will be, since it is 5 in diameter, will become 2.5 times 2.5. Our H is still 8 times 8, okay, which will give us 22 times 2.5 times 2.5 times 8 divided by 7. That will give us 157.143, okay, cm cube. Now we know that in order to find volume of metal casting, volume of metal will become volume of external minus volume of internal. So this will now give us volume of external is 509.143 minus 157.143. Okay, 509.143 minus 157.103 will give us 352 cm cube. So now 352 cm cube of the metal was used in casting this cylinder. So a quick recap of all we've learned in mensuration. 1, its volume is L cube. For cuboid, its volume is length times breadth times height. Now, for cylinder, its volume is pi r squared h. Alright, and for total surface area of a cone, which is TSA, total surface area of a cone, we have it as pi r bracket H r plus h, or h plus r. Okay, some call it L, some call it h, so whichever you feel comfortable with. Alright, and what again? We looked at pyramids. Now, our volume for pyramids, for the square-based pyramids, we have it as 1/3 pi 1/3 b squared h. Now for our cone, we have it as 1/3 pi r squared h. Now, in it all, one important thing to always remember is that your volume equals to area, base area base times height. Now, for each and every one of these, if you look at the area, this is volume. Let's look at area. Area of our cube will be, which is a square, will be length times length. Area of our cuboid will be length times breadth. Area of our cylinder, which is represented as a circle, is pi r squared. Okay. Area of our square-based pyramid, which is a square, which is length times length. Okay. Now, area of our cone, which is a circle, is also pi r squared. Now, you can see that each and every of them, their area times height forms the volume. Okay, so it is important to know that our volume is our base area, or area base, times height. Now, we also looked at how to calculate hollow objects and composite objects. Now, what are composite objects? Composite objects are objects that are made up of two solids. Okay, when two solids comes together, they form a composite object. Like our cone and cylinders, they form a composite object. Now, when we talk about hollow objects are objects that are not whole. They have a space in between them. Those are hollow objects. And in calculating composite objects, we are having in calculating composite objects, we have both solids, the volume of both solids being added together. We have the volume of both solids being added together. And in calculation of hollow objects, we are subtracting the volume of the smaller internal diameter from the external diameter. Okay, now, after having said that, we looked at frustums, which was what we did today. Frustums, in order to calculate our frustums, we'll do what? We form the whole cone, we make the whole cone, or form the whole pyramid from our frustum, then calculate total big cone, volume of our big cone minus volume of small cone to give us our frustum. Volume of frustum. Okay, volume of big cone minus volume of small cone will give us our frustum. Now, these are the key important things you need to understand in mensuration. But if there be any question you have, please put them down in the comment section and we will attend to it. Thank you for watching. We've come to the end of our tutorials on mensuration. If there be any question, like we said, put it down in the comment section. We will attend to it as soon as possible. Don't forget to like, subscribe, and click on the notification button to get more updates. Whatever topic you would like us to treat next, please put it down in the comment section and we will work on it.